what we are going to be doing today is we're actually going to have, is it better now, guys? Okay, so we are going to have the opportunity to practice elimination. Woo! Even more practice. It's my favorite. 2 of them are like really easy though, so don't. You got this. Okay, so let's take a look at our learning targets for today. Our learning targets for today, we have 1, we are picking up where we left off yesterday. Okay, so our learning targets for today are, number 1, I can explain why adding or subtracting 2 equations that share a solution results in a new equation that also shares the same solution. So when we do that canceling out, you know how like when we're doing elimination and we add the 2 equations together and then we get that bit underneath, that 3rd equation is going to have the same solution as the first 2 original equations. It's pretty cool. And we learned that through this idea of solving a systems of equation, there are 3 strategies that we like to use, right? There's the first one, and it's listed as number 3, and I didn't change it today again, is graphing. Graphing is a good way to check your work, which today we're going to be using graphing as a check for our work. So graphing is a good way to check for work. Another way that, or time that it's good to graph a systems of equation is when they're both in y equals mx plus b form, right? So that means when you have your y-intercept, which you plot, and then you plot you use your rise and your run, your slopes to continue the line and connect and create the equation line. Okay, so then you have substitution, which is really good when you have one of your equations in y equals form, right? So like y equals 5 or x equals 2x or 2y plus 7. When you have them with one variable isolated, that is a time that you might want to use substitution. Then we had this idea, which was new this week / last Friday, Thursday and Friday, of elimination. Elimination is when you actually physically add the 2 equations together to cancel out one of your variables. And then like solve for that y or that x and plug in and solve for your other variable. So it's pretty, I like elimination. The reason that we're doing so much work with these 3, with elimination really, is because last unit we had the opportunity to do a lot of work with substitution and graphing. So this time we're really focusing on elimination. But moving forward towards the end of this week, I'm going to be giving you systems, and you're going to have to choose which strategy you're going to want to use to solve them. So that's a heads up. So what we're doing this morning. So if you look, you have for our morning work today is 4, 5, 6, 7, and 8. Okay, so 4, 5, 6, and 7 consist of 4 systems that you need to solve. So if you look at, for example, slide number 4, you have to solve this. It says using substitution or elimination, but today I want you to solve all 4 of these using elimination. I'm going to say that one more time. I want you to solve all 4 of these using elimination. So what are you guys doing today? You're solving all 4 of these what? Let me know in the chat. Very good, Abby. Very good, Tyler. Very good. Junior, Sadie, Gwen, Adam, Ian. Very good. We're solving these 4 systems using elimination. So what I'm going to do is I am going to give you, let's see what time it is. It's 46. I am going to give you 15 working minutes, which is going to be plenty of time to solve these 4 systems using elimination. You have 2 options here. First of all, you can choose, you can do them in the box, which I personally like, or you can do them on a piece of paper and insert your work. That's how I did them. That's how I'm going to show you guys my work. Then after you do each one, you're going to check it using graphing. So you're going to, once you use the graphing tool, you're going to check. I checked it using graphing. You don't necessarily need to insert a picture of your graph on here. I just want to make sure that you are able to check it using graphing. I didn't insert a link to a graphing calculator, so I'm going to put that in the chat right now. So in the chat, if you look, give me 1 second, let me just make this go to everybody. Actually, I'm going to pause. I'm going to pause for a second. I want to talk about, I should have said this earlier. I put a bunch of grades into Power School yesterday, and a couple people's grades went down because there was a lot of missing work. So what I want you to do is I'm going to have a meeting this afternoon. Like, I'm going to have a Zoom meeting, and you're going to be able to join if you have any questions about your grade and or things that you think you did that you didn't get credit for. So just an FYI on that, I'm going to have a meeting from 1 to 1:30 if you have any questions about your grade. Okay, so here is, if you check the chat, here is the graphing calculator. You are taking 15 working minutes right now to solve these 4 systems of equation and using elimination and checking them using the graphing tool. Does everyone understand what we need to do? I need a yes in the chat. I'm going to get the timer ready, and you guys get ready to get started. Thank you, Max, Abby, Peyton, Sadie, Kyle, Gwen. I need a couple more people. Adam is ready. Let's see. I need everybody to tell me. Are you guys ready? Gabe is ready. Okay. Ian is ready. Cindy is ready. Junior is ready. Perfect. Ava is ready. John, are you ready? Are you ready? Okay. And I am starting the timer. And if you have questions, throw them in the chat and I can help you out. And I'm going to be checking in on, I'm going to stop sharing, and I'm going to be just going into your slideshows. So just an FYI. Okay, Junior, I like your strategy of getting them all written in the boxes first. Nice job. Connor, looks good, my friend. Making some good progress. Okay, John has clicked in the box. Let's get some stuff written, John, because it's already been 2 minutes. Nice job, Gabe. Ooh, Gabe is flying. Whew. You don't need to insert a picture of the graph, but I want you to check them all using the graph. So this is sort of like a, you got this. Ooh, Sadie, nice work there on number 1. Maybe it's letter A, I don't remember. Okay, Janessa, I don't see you in your document yet, Janessa. Let's try to get in there. Okay, so Nassim, we are on slides 4 through 7, and we are solving those 4 systems of equations. Do you want me to put that in the chat, Nassim? Perfect. Let me know if you have any questions, okay, buddy? So Janessa, I need you in your document, please. Missing somebody. I have to go through and figure it out. Sandy, Connor, Gabe, Gwen, Ian, Gabe, Gwen, Ian, Janessa, Junior, John. Nice job, Gwen. Kyle, Max, Nassim, Kyle. Nice job, Kyle Kelly. Awesome job, Cindy. Nice job highlighting those solutions there. It's a good strategy. Nice job, Max. Wonderful. We still have 9 more working minutes. Adam, are you doing yours on paper? So if you go into the chat here, Sadie, I put a link to the graphing tool. So if you go, it's probably not too far up for you. It's from me. It's a link to desmos.com. Here, I'll put it in the chat again just to make it a little bit easier. I'll send it again just to everybody. Here we go. Send that Desmos link again. Oh, so Adam, oh yeah, okay, perfect. Thank you, Adam. Just make sure those pictures get inserted once you're done. Nice job, Cam. Are you stuck, Cam? Oh, no, you're going. Perfect. Okay, so Ian, these look good. Like these look like good starts here, but 4 is not complete. 5 is not complete. 6 is not complete. I need a little bit more on all 4 of those slides. And it needs to be a little bit more, like a little bit easier to read, my friend. Okay, nice job, Tyler. That first one looks good. Nice job, Gwen. on that answer. Okay, these look good, Gwen. Thank you, Peyton. I'm just going to do one thing for you. Okay, nice job on those graphs there. Make sure you're putting parentheses around your coordinate pairs. Let me just click in here to make this go away because I don't. Nassim, how are you doing yours, my friend? On paper, or are you going to type them? Paper, perfect. Make sure you start inserting those pictures once you get answers, okay, bud? You're doing great. Nice job, Abby Wasta. Okay, Ava, how you doing yours, my friend? Ava, let me know in the chat, how are you doing yours? Perfect. Awesome, we're taking 5 more working minutes. Guys, you're doing fantastic. No, we lost somebody. Oh, no, we didn't. My computer keeps faking me out. Wonderful, we have 4 more working minutes. I like your emoji, Connor, by the way. Okay, so Junior, what's your first move here, good dude? I'm a little bit concerned here, Junior. Okay, so that means that you need to set up a time with me this afternoon. Can you send me an email and we can work something out, my friend? Okay, and I have a question. Did you watch any of the videos from last week that you missed? Okay, so I can do a mini little session with you this afternoon, but those videos need to get watched. Okay. Okay, so we'll take a look at 4 right now. Okay. Okay, ladies and gentlemen, we have 10 more minutes of class. So let's take a look at these guys. What I'm going to do, just give me 1 second. I need to just get my Zoom back over to my original screen, just because it moves a little bit better there. I'm going to share my screen and I'm going to close out this and I'm going to come to my graph here. Okay, so let's take a look at this first systems of equations. So we're looking at this systems of equations here. We have 2x plus 3y is equal to 7, negative 2x plus 4y is equal to 14. Okay, so let me I just want to pull this chat up just so that you can ask me questions as we're going. Okay, so we take our first equations here, and this guy here is ready for elimination because which variable has easily cancel outable pieces to it? The y? Yes, the x's, because remember, when we're looking for elimination, possible guys for elimination, we say to ourselves, okay, do they have the same number in front? Yes. Do they have opposite signs? Yes. So this guy is ready for elimination. So all we need to do is add our equations together. The two x's cancel out, and we're left with a 7y is equal to 21. Because we're adding the 7 and the 14. We divide by 7 to get the y by itself. Y is equal to 3. Okay, so once we get this y is equal to 3 here, we need to take this 3, substitute it in, and substitute in and solve. When you do that, you get 2x plus 3 times 3 equals 7. Subtract 9. 2x is equal to negative 2. Divide by 2, x is equal to negative 1. I had you check it using graphing, so I'm going to click over here. The first 2 equations here meet and match at, wait, did I type it wrong? No, here, let me, no, what? I must have typed one wrong, let me see. 14. Okay, let's look at it. Oh, no, it's 7, not 17. There we go, Mr. Main. There we go. Negative 1, 3. Very good. Nice, nice, nice. Now, if we look at this next one here, we have B. This guy also, we have our Y's that are ready for our elimination here because we have the same number attached at the front and we have opposite signs, positive, negative. So we can simply add our equations together. We get our y's cancel out. Our x's combine to or add to a 5x is equal to 10. Divide by 5 on each side. X is equal to 2. Now I take my x value, plug it into my equation up here. I know this 2 doesn't look really clear, but it's a 2. So 2 times 2 plus 3y is equal to 7. 2 times 2 is 4 plus 3y is equal to 7. Subtract 4 from each side. We're left with 3y is equal to 3. Divide by 3, y is equal to 1. My coordinate pair for this intersection, the solution, is 2, 1. Okay, if I come over here to check it, click my second 2 here. It intersects at 2, 1. Woo, nailed it. Okay. Voop. Okay, so now we're looking at C. C, we have this guy here. So this guy, we're almost there. We had to modify it a little bit because we had the same x's here, but they had the same sign. They need to have opposite signs. So to get one of these to have a minus 2y, x, we have to multiply one of them, all of the terms, by -1. Okay, so when I distribute a -1 here, my new equation is going to be written as -2x minus 3y is equal to -5. You could have multiplied the second equation by the -1. They both would get you yes. So yes, Connor. You could multiply the second equation by -1. It would still get you the same solution. And this -2x plus a 2x gets me a 0x, which I just didn't write because that means 0. Connor, do you see why I didn't write it there? Because it means the same thing as 0, and I just didn't want to take the time. I mean, I could have taken the time to write it, but I just didn't want to confuse you guys. Because in essence, it's canceling out and it's going away. So when you add these together, a -3y and a positive 4y, we get y is equal to 4, right? And then we take that 4 and substitute it into any one of our equations here. 2x plus 3 times 4 is equal to 5. Substitute it in. 2x plus 12 is equal to 5. Subtract 12, subtract 12. 2x is equal to -7. Divide by 2, divide by 2. X is equal to -3.5. Connor, does that make sense though why I didn't write the 0x there? I just want to make sure that you understand. Maybe? Okay. So, okay, perfect. So now we're going to graph it to check it. So I'm going to come into Desmos here. I'm going to click on my 5th and 6th one. Where do they meet? Where do they intersect? Oh my goodness, look at that. -3.5, 4. Woo, nailed it. Okay, the reason I sort of went fast through the first 3 is because the last one is where I want to spend a good chunk of my time to explain to you what we had to do here. Okay, so we're looking at this systems of equation here. Question for the chat. Okay. Oh, okay. Oh, okay. Yes, you could do that, Connor. Okay. That is another strategy. Question with this guy here. When we look at this guy here, is there anything that jumps out at me and says, hey, I can do elimination here? Connor. So easily, like right now, with no work done, can I do elimination here? Better question. No. Ooh, Sadie says something's jumping out at her. Good. Exactly. So nothing here right away is telling me that I can do elimination here. So I'm going to have to manipulate one of these variables here. And when you have an equation here and it tells you to use elimination and you're looking at it and there's nothing easily discernible here, Good, nice job, Connor. Very good job, Gabe. I just want to sort of, we have to say to ourselves, which one of these variables, if I multiply by something, is more likely to be equal to one another? The X or the Y here. So when I'm looking at, I'd have to multiply. So if we're looking at these Y's here, could I multiply one of these equations to get the Y's to be equal? If I'm not multiplying by a crazy number. No, right? Because if I were to, so for example, if I wanted to get this guy, if I multiply this by like 2, then it would be 6y and then negative 5y. So there's nothing easy. Like if I wanted to manipulate my y's, I would have to multiply this one times 5 and this one by 3 to get it to be 15y, like a common 15y, or I'd have to multiply by some crazy decimal, which is not the game that we're playing here. So we need to look at both of them, and these guys are not easily, nicely multiplied. If we look at this guy here, this 2x, 2 times 3 gets me 6x. 2 times 3 gets me 6. So if I multiply this first equation by 3, but I need them to have opposite signs. So we're going to have to multiply it by negative 3. We're going to have to distribute a negative 3 to all 3 terms here. Okay, I understand that this guy is a little bit tricky, but do you guys sort of see what I'm saying here? When you're looking at an equation and it's not easily eliminationable, I just made up a word, you want to look for one that is more easily manipulated. Perfect. Awesome job, Gwen. So nice job. Exactly, Gabe, on that one. Very good. So I didn't want to read that one out, though, because I wanted to sort of get there. So if we multiply all of the terms by negative 3 here, I mean, this is going to be rewritten as negative 6x minus 9y is equal to negative 48. Then I can do my addition of my sentences here, my 2 equations. My x's cancel out. You could do 9y plus negative 5y gets me a negative 14y. Negative 48 plus 20 gets me negative 28. Okay. And then you want to make sure that this stays a negative 28 here, because that's going to really mess you up if you do a positive. Divide by negative 14, divide by negative 14. Y is equal to 2 here. Plug my 2 into one of the equations, any one of the equations to be honest, and solve for an x of 5. Okay. If we come to our graphing calculator and we graph these 2 guys here, where do they meet? They meet at 5, 2, which is what we just said. Okay. So ladies and gentlemen, what we're doing this afternoon, you have some afternoon work that you're going to be going through. This is a little bit different than what we were doing in class today. There's not too many solving using elimination here. I'm going to attach this document to the classroom stream, and you're going to have the ability to copy any of this work down. One thing that I noticed when I was looking through PowerPoints, I've been noticing looking through PowerPoints, is that a lot of people are not giving me work. So like things that we do in class, you still need to get the work down and you need to get it into your slideshow. So a lot of people for the slideshow grades didn't get full credit. Actually, not a lot. Some people didn't get full credit because they didn't have their work pictures put in there. So my suggestion to you, I took a few slides out. Give me, I'll put the link in 1 second. I'll put it up on the classroom stream. Okay, Pete? So this afternoon, you're clicking on your Edpuzzle video. logging in through your school account and completing these slides here. In the video, I refer to slide 17 and 18, but I got rid of a few slides in here so they line up. The numbers don't line up, but the content lines up. Okay. So I'm going to post the link to the regular Edpuzzle video link on the classroom stream at 11 if you don't have access. So wait for it then. Okay. If you guys don't have any questions for me, I will see you guys tomorrow. If you do have questions, you guys can stay behind and ask them. I will see you tomorrow. You can say goodbye if you'd like. Unmute and say goodbye. Oh, Encore Today's Tech.